So yeah, this is another really interesting project I was involved with. Essentially the idea was to show visitors of this museum space how a windmill works or a wind pump works. And so it was to have a diorama, which is this landscape, and a wire art, wireframe windmill, but then to mechanically have it work the way a proper windmill works, so that again the viewers can see how a windmill works with a little pump unit down below, so you could see kind of a cross section of underground and the what do you call it? The water underground. I can't think of the term. So yeah, this is the little wire art windmill that was built by Ralph and his team. And these are some reference images of how wind pumps actually work. So the idea was that we were kind of to replicate that. So yeah, I jumped into Fusion 360. I think this was one of my first projects with Fusion 360, and as with always, I always dive deep into the unknowns. So figuring out Fusion 360, but a really awesome program I'm getting to know quite well. This is my initial idea, to kind of have a servo that would drive the shaft up and down. These are the gears. I was just prototyping in Perspex to get an idea of the concept. So a normal wind pump works with the wind blowing the blade, obviously, and then that turns these gears, and that in turn drives a shaft up and down, which pumps the water out. So there's obviously no wind in this diorama, so we had to drive this whole thing backwards, and that was the challenge of this whole project, as you'll see in time. Essentially, we were to drive the piston up and down, or the drive shaft up and down, with a servo, and that would in turn turn the blade. So in theory it sounded quite simple, but the reality was quite different. So here we drew up some parts and laser cut them out of steel. These are little bits of steel, or the gears are all steel. And here I'm drilling shafts and things in the steel gears, and then kind of soldering them together. So yeah, I was using this little butane blowtorch to join the different bits together. You can see here are some bits I've joined together. This is a little brass coupler that we use to drive the shaft up and down with the servo. And this is the main block with the gears, and you can see the longer shaft, that's where the blade goes onto. Yeah, that's more of the gearbox coming together. You can see this part in the middle that kind of is the piece that drives up and down. And that's it on top of the windmill. Yeah, this part all went very smoothly, and I thought, like, cool, we're on it, we've got it, no issues. And then you'll see the curveballs start coming in. Because again, the whole thing with this is how a wind pump normally works. Where my hand is the blade, and so it just turns around like that, whereas we were driving it from the bottom, and that changes the whole game. That's the blade on. So yeah, this was then the servo. This was the initial idea. I just put a servo on there and drive that little shaft up and down, which would drive the whole main shaft up and down. A little Arduino driving the servo. Yeah, you can hear it straining more. But
Yeah.
I can probably tune that a little bit.
Yeah.
I think that's pretty good for now. So there, yeah, you can see it kind of driving from the bottom up. And in the beginning, or it was totally random, but it was like, cool, got this, little bit of tuning and all sorted. It's crazy watching this back now and seeing it's there. Now you can see it's kind of jamming. But it would work a lot of the time, and then every now and then it would jam up. But yeah, I really thought with a bit of tuning and things that we'd get it right and it would work fine. And that was the very interesting thing with this project. You know, at what point do you call it and say, no, we got to redo something, and at what, you know, or versus continuing to tweak and adjust in the belief that one can get it right. But again, yeah, all in all, this seemed really good, you know. So we kind of thought we'd finished. It like kept leading us on in that way of like, no, it's like 90% there, but there was that 5-10% that was like, no. And yeah, you know, I think it's a big thing within life of really knowing when to call something or how long to persist with something when you're pushing versus when you're just surrendering and listening. So now you can kind of see how it seems to jam. It goes to the top and then stops because it doesn't have the momentum to go around. And it would sometimes do the same at the bottom. There, I think you can see it was, no, that was probably also at the top. But it was this weird thing. So yeah, as it says, back to the drawing board. So yeah, I figured, well, let's not use a servo and let's rather use a mechanism that actually has more of an elliptical movement. And this little wheel here, like so. And yeah, then that little notch there would be where we put the switch. So we can put a switch somewhere around here, we'll figure it out, to kind of know when it's in the center like that. There's a bit too much play here, but that's something we can tighten down in time. But I think, yeah, that's seeming good to me. You can definitely see how it slows down at the top, at the bottom, so that'll, you know, mimic the gear at the top more in terms of its changing of paces, something like that. So yeah, I kind of figured that the main issue was the servo was quite a mechanical up and down sort of movement, whereas when the windmill gears got to the top and bottom, it kind of slowed down and then sped up, and it was this thing of matching the two together. So I figured this kind of movement would have more of that elliptical curve where it kind of slows down top and bottom. So yeah, then also the switch was to stop it in place, because we had to stop it sort of halfway up and down, so halfway up or down, so that we could start going, because if it were to try and get it going from the top or the bottom again, it would jam. I'm not sure if you're following all of this, but yeah. Yeah, so anyway, that was the servo turning. This is a little Arduino modification, and this is the board kind of installed. And again, thought, cool, we got it sorted. And again, it really seemed good all in all, but then there were these same jams. Or maybe not same jams, but very similar, or a similar issue. And I think we realized that there's actually was so much play with this whole mechanism being wire and being like art crafty. Yeah, you can really hear that little servo motor straining. And although the servo isn't going up and down, it's a circular type servo, there was still quite a bit of strain. But it was the same thing, that it would like work a lot of the time, but then jam up as well. So I realized that to drive it actually needed a lot more subtlety and more of like a listening to where the blade at the top is, or where the system is before driving it, and not just driving it. So back to the drawing board, as I said, and came up with a system that more listened to where the shaft was, and then drove a little motor, you know, to encourage it along, in other words. Kind of more like a combustion engine with timing, like a car engine has timing. So yeah, back to the drawing board and drew up a little circuit to drive all of this stuff, which has, again, the switches to listen when the thing reaches the top and the bottom, and then changes the direction of the motor and drives it up and down in those directions. So yeah, this is the button here. This is the Arduino Nano with, I've got a relay there to change direction. This relay changes direction. This MOSFET PWM's the motor. Initially we had a smaller motor, but this is a pretty massive motor, so we're actually needing to PWM it to make it not as strong. This is a MOSFET that drives this little solenoid here, and this is a little 5-volt regulator because this little solenoid is actually 5 volts. So essentially when I push this button, it should happen. I'm going to try this. So right now it's blocked, and if I push the button, the solenoid should release and the arm should be pushed down, but then I might need to guide it a bit. But here goes. See, yeah. And then kind of goes back home. So here we have it, the Windmill, making progress, made progress, I believe. Got my laptop here and busy coding this Arduino to run it, and this is the motor mechanism down here with the gears and the cogs and all around that side. Pushing the button now. The motor driving the, what do you call that word? The pinion or whatever, and the blade at the top spins. Here I've got some feedback code as to what's going on in its correct position. There we are. Yeah, so this is the diorama installed. Really looked amazing. And the windmill. And yeah, at this point we also really thought we had it. And I definitely think we're a lot closer, but it's not quite there. So yeah, hopefully in time we'll be able to spend a bit more time on it when there's budget. To really get it finely tuned, because yeah, it's still a bit temperamental. A big part of this whole project again was this thing of a timeline, where we were kind of initially given 2 weeks, and thought to try and get it done in the 2 weeks, and that's why I think we kind of rushed into doing the first approach. Had I given it a little more time to kind of figure it out and think about it a little more, might have come up with a more mature approach as this is now. But then also, you know, the fact of this being like a wire sculpture, wire art type thing, where we actually need a lot of precision with no play for the driving side of it, is a very interesting merge of two very different spheres or realities or whatever you want to call it. Because essentially, yeah, we're driving this a bit like a car's motor, like a petrol combustion engine, where the piston drives up and down, which is fired by the spark plug or whatever. and then the flywheel follows, and that involves more involved timing and things like that, where yeah, a classic windmill is more the other approach of just the wind driving it around. But anyway, I think that's it for this video. Thanks for watching. Yeah, hope you enjoyed. Please like, comment, subscribe if you're inspired to. Let me know what you think, and check you on the flip side. All the best. Lots of love.